Good morning, dear students. Today we have the lecture by discipline interchangeability, standardization, and technical measurements. And there are team 7, lecture number 7, interchangeability and control of strength-sided splines. And write down to your notes the plan of our lecture. First item, classification of spline joints. 7.2, spline joints or connections with a strength-sided profile. Centering of spline joints, it's 7.3. And 7.4, designation of spline joints, connections with a straight-sided profile. Write down to your notes these 4 items of our lecture, this plan of our lecture. And we start item 7.1, classification of spline joints. You can see on these pictures, on these figures, the spline joints. Spline joints connections can be considered as a multi-K in which the Ks are made together with the shaft or bushing and are evenly spaced over the entire surface of the circle and parallel to its axis. Depending on the profile of the teeth, splines can be of 3 types: straight-sided, involute, and triangular. Straight-sided, involute, and triangular. Splined joints, splined or toothed joints, are joints formed by projections on the shaft called as splines, which feed machine grooves in the hub. Write down to your notes what is spline joints. Are joints formed by projections on the shaft called as splines, which feed matching grooves in the hub. And what is the spline joints? Let's see the first video about spline joints. Let's look at the first video, spline.
Splines are ridges or teeth on a drive shaft that mesh with grooves animating piece and transfer torque to it, maintaining the angular correspondence between them. For instance, a gear mounted on a shaft might use a male spline on the shaft that matches the female spline on the gear. The splines on the pictured drive shaft match with the female splines in the center of the clutch plate, while the smooth tip of the axle is supported in the pilot bearing in the flywheel. An alternative to splines is a keyword key. Those splines provide a longer fatigue life. Types. There are several types of splines. Parallel key spline, where the sides of the equally spaced grooves are parallel in both directions, radial and axial. Involute spline, where the sides of the equally spaced grooves are involute, as with an involute gear, but not as tall. The curves increase strength by decreasing stress concentrations. Crown splines, where the sides of the equally spaced grooves are usually involute, but the male teeth are modified to allow for misalignment. Serrations, where the sides of the equally spaced grooves form a V. These are used on small diameter shafts. Helical splines, where the equally spaced grooves form a helix about the shaft. The sides may be parallel or involute. This can either minimize stress concentrations for a stationary joint under high load, or allow for rotary and linear motion between the parts. Ball splines, where the teeth of the outer part are implemented with a ball bearing to allow for free linear motion even under high torque. Uses. Drive shafts on vehicles and power takeoffs use splines to transmit torque and rotation and allow for changes in length. Splines are used in several places on bicycles. The crank arm to BB shaft interfaces that are splined include ISIS drive, Trivative GXP and Howitzer, Shimano's Octolink and many others, most of which are proprietary. Some cranksets feature modular spiders, where torque is transmitted through spines. Cassettes engage the free hub via a spline that is one groove wider than the others to enforce a fixed orientation. Disc brake mounting interfaces that are splined include Centerlock, by Shimano. Aircraft engines may have a spline upon which mounts the propeller. There may be a master spline which is wider than the others, so that the propeller may go on at only one orientation, to maintain dynamic balance. This arrangement is commonly found in larger engines, whereas smaller engines typically use a pattern of threaded fasteners instead. Manufacturing, there are two types of splines, internal and external. External splines may be broached, shaped, milled, hobbed, rolled, ground or extruded. There are fewer methods available for manufacturing internal splines due to accessibility restrictions. Methods include those listed above with the exception of hobbing. Often, with internal splines, the spline portion of the part may not have a through hole, which precludes use of a pull/push broach or extrusion type method. Also, if the part is small, it may be difficult to fit a milling or grinding tool into the area where the splines are machined. To prevent stress concentrations, the ends of the splines are chamfered. Such stress concentrations are a primary cause of failure in poorly designed splines. See also, hearth joint, key joint, reading, coupling. References. Further reading, Robert Rich Robbins. Tooth Engagement Evaluation of Involute Spline Couplings. Brigham Young University. Retrieved July 8, 2010.
And now we are continuing classification of spline joints. According to the shape of spline, joint with straight-sided splines. Straight-sided splines. Joint with involute splines. You can see involute line So it's joint with involute splines. Joint with triangular tooth splines. You can see triangular splines. It's according to the shape of splines. Second, according to the depth and number of splines. Light series, medium series, and heavy series. Light series, medium series, and heavy series. Internal and external spline teeth. The tool machines and extensive hobbing and cutting tools available to us allow us to achieve external and internal spline connections according to the standards DIN, BS, AGMA, ONF on gear blanks or workpieces, of which the dimensions fall within the limits of our manufacturing capabilities. This applies both to spline connections with involute flanks as for spline connections with strained flanks. Write down to your notes this figure with internal and external spline teeth. Spline joints. Advantages. Spline joints offer a higher load carrying capacity owing to an increased contact area. They permit better alignment of the matting parts. Stress concentration is less pronounced and the roots of the splines than in case slots. Spline joints are easier to manufacture. They can be made to a higher degree of accuracy. Spline joints compared to case ones transmit more torque, have greater endurance strength, and higher centering accuracy. So please write down to your notes advantages of spline joints. All these advantages write down to your notes. Spline joints connections with a strain-sided profile. It's a most popular slide, spline joints. So item 7.2, spline joints connections with a strain-sided profile. The most widespread are spline connections with a straight-sided tooth profile, the lateral sides of which are parallel to the axis of symmetry of the tooth until they intersect with a circle of diameter small d. The standard specified the number of teeth, the nominal dimensions of such a light, medium and heavy series connections, as well as tolerances and fits for connections with centering on the inner outer diameter and on the sides of the teeth. Spline connections with a straight-sided profile. Spline connections with a straight-sided tooth profile are characterized by three sizes. Small d, you can see it's on this figure. Small d, its internal diameter of splines. Big D, its external diameter. For example, from this point to this point, its external diameter, big D. And B, you can see B on this figure and on this figure. Between these parameters, due to the imperfection of the technological processes of processing, there are errors in the relative position of the connection elements, which do not make it possible to perform centering on three-dimensional parameters at once. Since the type of alignment is directly related to the choice of tolerance fields for individual elements of the connection and their fit, the assignment of tolerances is determined by the adopted method of alignment. Write down to your notes these two schemes. It's external splines of the shaft and internal splines in the hole, in the body. And now we start item 7.3, centering of spline joints. Outside diameter centering, big D. Outside diameter, you can see on the figure. Where is outside diameter? It's diameter on the, from this point to this point. And in the shaft, you can see outside diameter, big D. 2 is the simplest and most economical option and is recommended when the bushing is not yet treated or when its material is hard enough to be sided by pulling and the shaft material is milled to final tooth sizes. In this case, the centering surfaces, outer diameter big D and spline with small b allow for precise and productive processing, the bushing by broach and the shaft by round grinding. Due to the low strength of the bushing, this method is used for fixed joints nowhere, as well as for movable ones that perceive small loads. Centering of splined joints and centering on the inner diameter, small d. Small d on the figures, it's for shaft and for hole. Small d, internal diameter, is advisable in cases there where the bushing has a high rigidity and cannot be machined by finishing broach. Then the final dimensions of the bushing are obtained after head treatment on conventional intra-grinding machines. This method provides precise centering and is commonly used for moving joints. And the third type of centering, centering on the side surfaces of the teeth. B. Is used in cases where the centering accuracy is not of particular importance, but it is required to ensure sufficient strength of the connection in operation with alternating loads, high torque use, etc. With this variant of centering, the load is more evenly distributed between the teeth. However, centering details are less accurate. Recommended fits. Before we start the recommended fits, I want to show you another videos about splined connections.
Today, we're going to talk about axle spline. One of the most frequent calls we get is, what is an axle spline, or how do I measure an axle spline? Well, the axle spline is the peaks and valleys on the end of an axle that slides into the differential or spool. When we ask you what your spline count is, what we want you to do is count the number of peaks on the axle. Here in front of me, we have some of our most popular axle spline, starting with the 26 spline C-clip axle and progressing all the way up to our 40 spline race axles. This is our 26 spline OEM replacement axle. It measures just over an inch in diameter. This is our 40 spline, which measures just over 1 3/4 diameter. When you have more power, you need more spline. Another question we often get is, when I replace my OEM axles with a Mosier axle, how much strength am I going to obtain? Well, the Mosier axle, comparatively speaking, spline to spline, is approximately 30% stronger than your OEM axle. This is one of our C-clip axles. Typically, these are found in OEM type vehicles, including GM 10 and 12 volts and Ford 8.8s. They serve the OEM industry well and provide adequate support for these types of vehicles. However, when you start making more horsepower and put them in a racing environment, you need more strength than a C-clip axle can handle. Once you get to that point, Mosier recommends a bolt-in style axle. It is far safer than your OEM style C-clip axle. If you have a problem in the differential or with the axle spline breaking, you don't want the axle exiting the vehicle. We're often asked, what is a contingency paying axle? We recognize 30 spline or above, or the equivalent of 1.285-inch diameter axles that are also positive retention. But in order to qualify for any money, you have to run 12-inch decals on both sides of the vehicles, along with the Mosier end cap visible at the time of the race. We offer a 10-year warranty on all 33 spline and larger positive retention axles in a drag racing environment. In order to qualify for a warranty, it must be on an asphalt or concrete type racing surface. If you're not sure what spline your application calls for, give us a call at 260-726-6689. One of our knowledgeable technicians will be happy to assist you.
And how cut two splines on the
sticking out the sides of farm and garden equipment,
less
like
machine.
electrical outlets, but for mechanical power. You'd plug other stuff you want to power onto them, like log splitters or mowing attachments, that sort of thing. I've never cut one of these before. And after learning that it's some sort of hack backyard project, and more importantly, no one can get hurt here except their wallet, I said, what the heck? First thing I had to do was find information on the 1-inch 6-spline PTO shaft. Of course, I turned to the machinery's handbook. Fortunately, this thing has all the information I'll need to pull this off. And since I'm only responsible for the actual spline, we'll knock this back down and take it over to the mill. You likely saw this coming, but I'm set up in the dividing head. I didn't make this part. This is as received. The owner, from what I understand, has a lathe and a welder, and on close inspection, probably also an angle grinder. That, or more than likely, they tried to test fit this on a bearing or whatever this attaches to. Best I could do is get this thing centered to within about 1.5 thou. That's total run out. After 20 minutes, I've given up and calling that close enough. According to the good book, if I do the rest of this right, I should still be in tolerance. That and their finished OD, where the spline goes, is a bit undersized. Let's pontificate a moment, shall we? Without being a complete and utter geek about it, of course. Here's what I think happened. They held onto this part here, same place I'm grabbing it with my dividing head. Probably obvious enough, right? And turned down the features that they needed. The 1.5 thou I'm seeing now is from their 3-jaw chuck. It may be a little is coming from this 3-jaw too, but I bet most of that was just their chuck and working off the OD of raw stock, which is fine. They also took a skim cut here on the large diameter, and if we could cut the back of this part off, we could grab that and be in a better situation, concentrically speaking. But they either went to town on this and took their measurements hot, or they used an older, worn PTO to figure out what the dimension should be. In either case, our major diameter is now undersized. What does that all boil down to? Well, I'm not going to volunteer for the extra work to get this thing dead nuts, or in metric, spot on. I agreed to do this for a couple of reasons, and on the premise that I might not be able to pull it off. First, like I said, I've never done anything like this before. I've never cut a PTO spline. And second, I don't have the right cutter to do it. All I have is a regular milling cutter. I'm curious to know if I could approximate the PTO spline using one of these. These splines have a minor diameter. That means in between the splines, it's round. And technically, I would need a form cutter of the right size to do this. Something that in one pass would leave a finished spline profile. This cutter is going to leave that minor diameter a bit faceted, I guess, depending how much I approximate it. Hopefully that'll make more sense as I work through this, if this works at all. You might be wondering why I'm not using just a regular end mill for this, and that's good. I briefly considered the same thing. Using a regular end mill like this to cut the splines would result in an abrupt end to that feature. Like where it stopped, it would look like a key seat in the shaft, just like a sharp inside 90-degree corner. I couldn't find anything specifically in the book. I didn't dig too hard, but PTO shafts usually have that cut feature taper out. So if I come in here with a milling cutter and do the same groove, that cut will feather out. It won't stop abruptly. I don't know if that's necessary, if it's done to reduce stress concentrations, or if it's just a result of the manufacturing process. In either case, I'd like to mimic that lead out on the spline cut. So I'm going to use one of these. Somehow, all of a sudden, it's the next day. Time flies when you're having fun. Got the milling cutter mounted on my 80 RPM 0.5 inch per minute mandrel, 12 to 13 millimeters per minute. A bit perhaps on the conservative side, but this looks to me like a reground cutter. I've never used it. It feels sharp, but I don't know how well it's going to do. I'm going to start off slow and see how it works. I've snuck in behind here to pick up the height of the workpiece, the top of the workpiece. I'm going to use that to set the height of the cutter. And this is what I end up with after 12 passes. I did 6 cuts on one side of the spline and then 6 on the other. It's left me with these little pyramids here. That's the faceting I was talking about earlier. I'm now going to come in, 6 more cuts and try to knock those out. We'll see how that looks and take it from there. And there it is. It's probably not going to end up on the cover of National Geographic, but according to the numbers, this thing should work. I did my best to get in there and deburr it with a couple of small files and a stone. I didn't do an exceptional job.
And another video about milling of splines on the machine with CNC. And the last video, previous video, it was about external splines, and now how it can be made for internal splines, cutting or milling of internal splines. And we are continue with our presentation, recommended fits. The standard established recommended fits on spline dimensions depending on the centering method. 20 tolerance fields have been established for the centering surfaces of the shafts of grades from 5 to 10 with the fundamental deviations D, E, F, G, H. For the formation of clearance fits as well as JS, K, N for transitional fits. For non-centering surfaces, it is established when centering on the inner diameter, small d. For the outer diameter of the shaft, the tolerance field is A11. For the outer diameter of the bushing, H12. So A11, H12. For the shaft, A11. For the bushing, H12. When centering on the outer diameter, big D. For the inner diameter, the tolerance field H11 is set for the bushing. And for the shaft, the tolerance field is not standardized. The numerical values of the main dimensions and tolerances are taken as the standard for smooth cylindrical surfaces. And now we start item 7.4, designation of spline joints connections with a strength-sided profile. The designation of spline joints and their parts includes the method of centering. Method of centering for the first place. For internal diameter, for example, small d. Method of centering. The size of its main parts and their fits, its number of teeth, 8 teeth, and then small diameter, nominal diameter, small d, outer internal diameter, outer diameter, big D, and B, it's equals 7. Under the line, above the line, you can see the parameter for the hole, for the bushing, and under the line, the parameter, the fits for the parameter of fits of the for the shaft, for the bushing, for the shaft, bushing, shaft. It is allowed not to indicate the tolerance of non-centering diameters in the designation. Non-centering diameter for this designation, it's big D and B. You can see centering parameter, it's small d, so you can see H7 divided by E8, it's for internal diameter small d. And for the non-centering diameters, the fit is not designation. Without fit. Only big D and only B. An example of designation of a connection with the number of teeth that equal 8, inner diameter 36 millimeters, outer diameter 40 millimeters, tooth with 7 millimeters with centering on the inner diameter with feet on the centering diameter. H7 E8 and size B D9 F8. Centering diameter small d. Non-centering diameter big D H12A11. And centering parameter small d. Number of teeth 8. Nominal diameter on the inner diameter small d is equals to 36. Nominal diameter of external surface big D it's equal 40 and B it's equal 7. And you can see the parameters of the feet in the internal diameter, outer diameter, and in the connection by B. Write down to your notes this example of designation of spline connections. And it was the last slide for today. Our presentation is finished. So, if you have questions, you can write it in our Telegram group. And see you next time on the next week, in the next lecture. Have a nice day. See you later. Goodbye.